Hello, boys and girls. I hope it was a great day for you and that you could took advantage of the time that you had to get things done and make yourself a better student, and that you just don't have any missed opportunities today when you lay your head on the pillow tonight. Anyway, welcome back. Today is a short talk, or should be short, talk about solutions and solubility and factors that affect solubility, and then reading solubility tables. So this should go fairly quick. I don't think there's a whole lot to be done by way of heavy lifting or anything like that. This is not really tough stuff. And the good news is, again, you've seen 80% of this, so there's not a lot of really new stuff with this. So you guys should be okay. All right, so without dragging the introduction out anymore, let's go ahead and get started. Solutions are homogeneous mixtures, and you guys know that. Homogeneous mixture means one phase, of course. We've dealt with this, so if I've got a pen that writes, so this is one phase, okay, as opposed to two phases. So this would be analogous to Gatorade or Windex or something like that, or air is a solution, steel, anything like that. So when table salt is added to water, a solution forms. It dissolves, obviously, meaning there is no layer of salt. Again, so this is one layer. Okay, that forms. Table salt is known as the solute, and water is the solvent. I guess, a generic definition for solute. This is the thing that gets dissolved, which you guys know. And then where are we here? Whoopsie, we're way over there. This guy, the solvent, does the dissolving. Okay. During the dissolving process, what you've got is the forces of attraction that hold the solute particles to each other are broken and replaced by a force between the solute and the solvent. In other words, if we're really looking at any bit of this, right, the force of attraction, and we're going to pretend that water is going to be your solvent. It is most of the time. So the force of attraction between H2O is greater than the force of attraction. I seem to have lost my cursor again. There we go. Is greater than the force of attraction between solute particles. Okay? So in other words, there's the attraction to the solution more so, or the solvent more so than each other. And so because of that, it breaks down and it dissolves, and you don't see it. It becomes one phase. This process, you guys have known this term. We've used these a lot. This process can be exothermic, meaning just by splitting this up, we're going to release heat into the solution and my temperature rises. Or it's going to be endothermic, meaning absorbs heat from said particles into solution, and it's going to feel cold. And it feels cold because your temperature, your heat energy, your body heat is going to drive that process to make it go. Okay, so that's what a solution is. Now, predicting solubility is a little bit different. We knew this from the last unit, so let's review, because some of you guys got this wrong, and we can't have that with this. In the previous unit, it says we discovered like dissolves like. Man alive, if you are going to remember anything about solubility, that's one of the most important things. I'm going to try and highlight that if I can find my cursor here. There we go. Like dissolves like. Big deal. What does that mean? What that means is polar dissolves polar, and nonpolar dissolves nonpolar. Okay? So you can't have a polar substance, so these are either both polar or both nonpolar. So you can't have a nonpolar substance dissolving in a polar substance or vice versa. And again, this, for lack of imagination, this is your oil and water example. Oil and water. Okay, we know water is very polar. Okay, and oil is nonpolar. The last time I checked, they don't mix. Um, Equals no solution. Okay, so what we've got here is polar substances will dissolve in polar substances. So the more polar something is, the more readily it will dissolve. And nonpolar won't dissolve in polar substances, as we've said, but they will dissolve each other. So oil will take out oil stains. WD-40, believe it or not, you can put on your clothes to get out oil stains. You'll smell like WD-40, which may be attractive for some people. I don't really know. So that's the deal with polarity. So make sure you know that whole thing is like dissolves like. Some of you guys had some sort of funky notion. I don't know who taught you this. It wasn't me, but you were talking about the nonpolar substances having weak bonds, so water can overpower those. It had nothing to do with that. You've got to have some form of attraction for water, and so water, because it has hydrogen bonds, are seeking out and looking for these partial negatives and partial positive charges, or full partial. Check that, full positive and full negative charges. Well, ladies and gentlemen, that's probably it as far as solubility is concerned. The next screencast will cover some factors that affect solubility. So how do we increase or decrease the amount of stuff we can dissolve in solution? We'll also spend some time looking at solubility graphs and determining if something is saturated, unsaturated, or supersaturated. How do we get those? We'll also, from those graphs, be able to discuss an amount. How much is saturated for one solution and why that might be different from another. But we'll save that for another day. Well, listen, I hope you had fun. I hope you learned something. I hope you're a better student. Really, that's what it's all about. So thanks so much for dialing in, and you guys have a great day. Go do something nice for somebody.